What makes a superhero super? Is it magic? Is it talent? No, it's science. By looking at the science of superheroes, we can better grasp the real-world concepts around us. In this video, we will analyze Wolverine's powers and demonstrate what puts a super in this superhero. Wolverine is a mutant with extraordinary adamantium claws and superhuman healing. These factors make Wolverine one of the most durable combatants in the Marvel Universe. Wolverine is often affiliated with the X-Men, a superhero team that protects the innocent from harm.
One of Wolverine's most impressive biological superpowers is his incredible ability to heal himself. Let's look at this clip that puts in perspective how fast Wolverine's healing process has been depicted. After a normal person is injured, blood flows to the damaged area, which carries white blood cells to fight infection that can occur at the site of the injury. Platelets in the blood are activated when a blood vessel is damaged, and they act as a plug by sticking to nearby tissue and each other. Then, the fibrous protein fibrin, which acts as the tougher mesh scab over the clot, starts to form. The scab protects the injury as the process of mitosis replicates cells to replace the damaged ones. For Wolverine, his mutations allow him to perform these processes of blood clotting and mitosis at incredible speeds, which can be called hypermitosis. This process is so fast for Wolverine that he does not even seem to form a scab. His body is exceptional at stopping the flow of blood quickly and instantly forming skin cells over the wound. In addition, Wolverine has powerful white blood cells with quick reaction times that are extremely effective at neutralizing toxins, which could come from attempts to harm him using poison. Another superpower that works hand in hand with healing ability is how Wolverine never seems to age. Aging typically occurs in humans because of errors in DNA replication, in which bases are inserted incorrectly or proteins are mixed up or lost. These mistakes can then form wrinkles or cause diseases, which are the normal signs of aging. Wolverine's DNA replication has been perfected to avoid these rare errors, and the hypermitosis that makes his healing process more effective must only take place after injuries to avoid the opposite effect of aging more rapidly than normal.
Now let's look at the chemistry behind Wolverine. Wolverine's skeleton is made up of adamantium, which is a fictional metal alloy. Adamantium doesn't exist in the real world, but we can explore the properties of alloys that make Wolverine indestructible. In simple terms, an alloy is a combination of at least two metallic elements, usually melted together and then cooled. Alloys have numerous benefits, including greater resistance to corrosion and increased durability. Alloys also have stronger intermolecular forces, or bonds between its molecules, than individual metals themselves. This means that the bonds in alloys are really difficult to break, giving it a higher melting and boiling point. This explains why Wolverine can have fire claws and even withstand nuclear blasts. Additionally, alloys which combine two or more metals are less malleable than individual metals, meaning it's more difficult for alloys to be pounded into sheets. This is because individual metals have one element with one type of atom, making it easier for cations to slide over one another when it is pounded. On the flip side, alloys are comprised of multiple elements, each with different cations, which makes it really difficult for that cations to slide over one another and adjust when it is pounded into sheets. In turn, alloys' rigidness explain why Wolverine is often described as indestructible.
Wolverine can create scenes that defy many of the laws of physics. For example, he can cut through human flesh, steel, wood, and much more with seemingly no effort at all. In a scene in which he battles Agent Zero, he reaches out and cuts directly through an entire Hummer with his claws. His arm does not move back in the slightest, completely defying the Newtonian laws of physics. Also, the car is launched into the air at a height that causes a helicopter that was chasing them to swerve out of the way. The amount of force it would take to launch a 2,000 340 kilogram object 152 meters in the air is far greater than Wolverine should be able to exert. Another example we can look at is when Wolverine is fighting Gambit on the street. From the ground, Wolverine looks up at Gambit as he's on top of the fire escape of a building. Wolverine begins to slice off the bottom support of the fire escape with his claws. Rather than the fire escape falling off the building as it would in real life, the stairway comes off of the building right next to Wolverine. He quickly slashes at the bottom of the stairway foot by foot as Gambit stays at the top of the fire escape and slowly makes his way down to the ground. This completely rejects gravity as the fire escape seemingly hangs in midair. It should have been falling down with an acceleration of 9.81 meters per second squared.
In Wolverine movies, computer science makes the impossible possible. In the movie X-Men Origins, Wolverine, a nuclear explosion is shown decimating a town. The atomic explosion was made possible through the use of many algorithms, including computational fluid dynamics, computer graphics, computer vision, and computer biomechanics. Another use of computer science is seen in the movie Logan. In Logan, a de-aged version of Wolverine is shown to the audience. Computer scientists were able to make this possible by manipulating the facial scans of the actor Hugh Jackman. The computer scientists would remove details from the scan and change specific features, such as the forehead and eyes, to create a de-aged Wolverine. However, the real challenge stemmed from having the young and old Wolverine on the screen simultaneously. To solve this problem, the computer scientists took the de-aged scan of Wolverine and seamlessly attached it on top of another actor to show both versions of the character on the screen at the same time. Another excellent example of computer science in Logan was the creation of the setting and scenery in the movie. To do so, the computer scientists took the original location and supplemented it by adding digital matte paintings and CG vehicles.
In the movie Wolverine Origins, the audience is presented with an X-ray picture of Wolverine's forearms, allowing them to see how exactly his claws, one of his two central mutant abilities, are housed throughout his body. The picture shows that all three of Wolverine's claws are placed between his radius and his ulna bone, with his first claw extending between his lunate and his scaphoid bones, and his second and third claws extending past his triquate and his lunate bones. His claws continue to develop through his hamate, capitate, and trapezoid bones and project out of his hand in between his pinky, ring, middle, and index fingers. Then this indicates that all three of Wolverine's claws should be able to fit inside of his forearms when resting. The official length of Wolverine's claws are 17.8 inches each, as listed by the official Marvel trading card, and because of this, he should not be able to move his wrist. In X-Men Days of Future Past, we see Wolverine bending his wrist in order to hold onto a bus. However, this feat should not be possible. His official height, according to the Wolverine comic book, is 63 inches, which translates to 160.02 centimeters or 160 centimeters. The X-ray shows us that these claws take up the length of the entire forearm and spread out once Wolverine activates them. A human that is 160 centimeters would only have a forearm length of 26 centimeters, or 10.263 inches. This means that Wolverine's claws are 7.5 inches too long. In this case, all three of his claws should be extending far into his arm, preventing him from moving both his wrist and elbow at all times, and only preventing him from moving his wrist when he has his claws out. On the topic of his skeletal structure, Wolverine has an adamantium-coated skeleton, which we are shown to being injected in Wolverine and Wolverine Origins. Adamantium is a fictional metal that bears the most similarity to solid graphene, according to the creators of Wolverine. This metal coating adds 105 pounds of extra leg weight to Wolverine's body. However, although adamantium allows Wolverine to be impenetrable, the increased weight adds added pressure onto Wolverine's joints and ligaments, which over time and after repeated use and repeated motions, this would gradually wear down his tissues between each joint, ultimately leading to health conditions such as osteoarthritis.